Okay student, now we are going to start with our unit number 6, illumination models and surface rendering methods. So the first we are going to see which points are in this unit we are going to cover. So it includes light sources, different light sources we are going to study, basic illumination model, displaying light intensities, halftone patterns and tethering techniques, polygon rendering methods and ray tracing methods. Initially we are going to see only the definition, what is actually meant by illumination model and surface rendering, and then we start with the light sources. Illumination model, it is also known as lightning model or shading model. What is it? It is the model for calculating the light intensity at a single surface point of a particular object. Means at a particular point on the object surface we find out its light intensity. So that is known as illumination model. Now, what is surface rendering? Uses the intensity calculation, means whatever the light intensity we calculate, using these intensity calculations from an illumination model to determine the light intensity for all projected pixel positions for various surfaces in the scene. So for particular point first we find out the light intensity and then we find out it for all pixels on that particular scene. Now how we actually see an object, that is important. How do you see an object? So light from the object enters into our eye. So do you see all objects in the same way? Is it? No. There are two ways to see the object. You see some objects because they are light sources. We generate their own light. These are objects with the light sources. And you see other objects by reflected light. Means these are not generated light sources, they are generated reflected light. So these are the two ways in which we can see the object, either light sources, the objects which has its own light sources, or the objects by reflected light. Now we are going to see it with example. So seeing a luminous object. So what is luminous object? Luminous object gives out light and can also called a light source which has its own light source. Now how does light from a light bulb? Light bulb is example of luminous object. So how does the light from a light bulb and other light sources reach our eye? So that is shown here with simple way. So here direct light travels in a straight line directly into your eye. So you can see here the light from the luminous objects such as this bulb, straight line directly into our eye and we can see that particular object. Now non-luminous objects. So objects that do not give out light are non-luminous object. How does you see a non-luminous object such as book? Why? Because book does not have its own light. Now we see it through the another luminous object. So in this way. So light from the light source, light from this light source, it strikes on the book and some of the light is not all, some of the light is reflected into your eye and you can see the non-luminous objects such as book. That is the simple way in which we can see the luminous and non-luminous objects. So always remember, in luminous object, light, straight light from the object, luminous object enters into our eye, and in non-luminous it is reflected. Now how we see the color? Different colors, means if a red color dress is there, how we see the red color? If it is a green color dress is there, how we can see green color? So different colors how we can see with our eye. So examples, some of the examples we are going to see. White light is a mixture of 7 colors or 7 colored lights. So red, orange, yellow, green, blue, indigo and violet. All these 7 colors together generated the white light. Now why does the red snooker ball look red in white light? If white light is there and red ball is there, why it looks white? Okay, see, so this white light is made up of all 7 colors of spectrum of colors and this generate a red color. So the snooker ball absorb all the colors of the spectrum. So this snooker ball is observe all the, so this snooker ball it absorbs all the colors of the spectrum. All the 7 colors are observed by this spectrum except the red color. Why? Because this ball is of red color. Only red light is reflected into our eye, so the Snicker ball appears red. That is the simple technology, that these 7 spectrums are observed by this ball, but only red is not, and that red is reflected into our eye, and we can see the color of ball as a red color. Now, why does a green snooker ball looks green into our eye? Again the same method. Here this one, you can see all the spectrum of colors are absorbed by this green snooker ball, but only green color is except the green color. So, only green light is reflected into our eye. So, snooker ball appears like green. Now, why does a black snooker ball look like black in white light? So, all these are related to the white light. Background is a white light. So, the snooker ball absorbs, if it is a black color ball, then the snooker ball absorbs all the colors of the spectrum. No light is reflected into our eye, so the snooker ball appears black. So, no light is reflected into our eye, so it appears black. Now, about the white color. So, why does a white snooker ball looks like white in white light? So, again same, the snooker ball does not absorb any of the colors of the spectrum. See, in black color it absorbs all the colors, and that is why does not reflect any color and we see the black color. But when we consider a white color, the snooker ball does not absorb any of the color of the spectrum. So, whole spectrums as it is, you can see here, all the spectrum, all these 7 spectrum, all as it is reflected here into our eye. So, when all these 7 colors together, it generates a white color. So, in that way we can see the white ball as a white in white light. Now, why does a magenta ball look magenta in white light? So, when we consider a magenta, it is a combination of 2 colors. So, as spectrum is generated, and this spectrum, among these only the snooker ball observe all the colors except red and blue. Why? Because red and blue together it generates the magenta, and red and blue are reflected into your eye. So, the snooker ball appears magenta. Now, up to this we have seen how we see the color balls different, such as red, green, white, black, magenta in white light. But if there is a light of different color other than white, so why do colors look different in different color light? Instead of white, if we keep a blue color light, if we keep a red color light or green color, blue color, then in that case we can see the different color for the particular ball. Now, we are going to see it with example. Consider a red ball in red light. So, if red ball, consider a red ball in red light. Now, the red light shines on the ball. The red ball reflects the red light and so appears red if red light and red ball is there. What color does a red ball appears in a green light? The green light shines on the ball, and the combination of these two, the red ball only reflects the red light and so it absorbs the green light. So, in the green light this ball does not reflect any light, so appears black. So, we can see the red ball in green light as a black ball. You can also observe this as you can do the experiments at your home also. What color does a green ball appears in the blue light? If green ball is there and blue light is there, so the green ball only reflects the green light, so it absorbs the blue light. So, in blue light this ball does not reflect any light, so it appears black. So, these are some examples, different examples are shown here in this one. Now, this combination of colors are shown in this PPT. The color of a non-luminous opaque object, non-luminous opaque means which is non-transparent object, depends upon the color of the light reflected by it. The color of light is important here. The color of the reflected light depends upon the color of the incident light. So, white light, all colors are reflected. If there is a white light, we have seen the example, red ball looks like red, green ball looks like green, black looks like black, magenta looks like magenta, means white color, all colors, white light, all colors are reflected. Then white light, no color, if this is a black, no color is reflected for black, red color is reflected as red, and green color is reflected as green. If there is a white light, the color is reflected as it is. But it is if it is different, then different colors are generated, and that is shown here in this also. So, if blue object, it looks like blue. Why? Because it observe all the colors other than blue, and the blue light is only reflected. In the second case, here the book or this object is of red color, so it does not observe red color, reflect only red color, so it appears red. Here also white and black, so in black it observe all the colors, so it appears black. Now, Illuminous model and surface rendering, we already seen the definition, again we repeat it. Illumination model, it is also known as lightning model or shading model. It is used to find out the light intensity at a particular point. And surface rendering means using this intensity calculation, we find out the intensity of all pixel positions for the various surfaces on the scene. Now, what is surface rendering? Surface rendering can be performed by applying illumination model to every visible surface point or by interpoling intensities across the surface from a small set of illumination model calculation. Now, scanline algorithm use interpolation scheme. So, interpolation we have seen in the previous unit also, that point. So, you can read that definitions for this interpolation. Approximation and interpolation. Ray tracing algorithms invoke, these are only the definitions, again we are going to study it in detail afterwards. So, ray tracing algorithm invoke the illumination model at each pixel position. So, at every pixel position it invoke a illumination model and find out the light intensity at that particular pixel position. Surface rendering procedure are also known as surface shading method. Now there are two methods. First one, the model for calculating the line intensity at the single surface point at a particular position or point as a known as illumination model, and if we use it for a particular scene, entire all the pixel, then it is known as surface rendering. Now, suppose we have given some of the parameters, the optical properties of surface, whether it is opaque or transparent object, whether it is shiny or dull object, whether it is surface or object, the position of the surface in a scene, what is the relative position of the surface, the color of and position of the light source, means whether it is a white light, whether it is a green light, then using that also we can calculate the light intensity, the position and orientation of viewing plane. So, illumination model calculate the intensity projected from a particular surface point in a specified viewing direction. So, using all these parameters, how we can find out the intensity, again we are going to see in detail. Now, we start with the different light sources that we can use for find out the intensity. When we view an opaque non-luminous object, opaque non-luminous means non-transparent object, we see reflected light from the surface of the object. Already we have seen the example such as book. The total reflected light is the sum of the contribution from light source, means it is include the contribution of light source and other reflecting surfaces in the scene. So, whatever in the scene, all these together, combination of all these together is the total reflected light. So, light sources, it is light emitting, also known as light emitting sources, and reflecting surface, light reflecting sources. So, that is shown here, it is a non-luminous opaque object. So, here this light is reflected and you can, for eye it is shown like a here in this case, here in this case you can reflect or you can see light reflected is of orange color into our eye, or in this case it shows the blue light. Light sources. So, a luminous object can both a light source and a light reflector. It works as a both light source and light reflector. Example, a plastic globe with light bulb. So, this is one of the example of luminous object. Point light source. So, the simplest model for a light emitter is a point source. The rays emitted from a point light diverge from the source. That single point, you can say here in this diagram, red point is there which generate the light, and the rays emitted from this point light are diverged from the source. This model is approximation for the sources whose dimensions are small compared to the size of object in the scene. A point light source is a fair approximation to a local light source such as light bulb. It is approximation to the light bulb. The direction of the light to each point on the surface changes when a point light source is used. So, direction is changes. Now, distributed light sources. A nearby source such as long fluorescent line. So, that is shown here in this diagram. So, that is a long fluorescent light. All the rays from a directional or distributed light, it is also known as directional light source, have the same direction. You can see here it all have the same direction and no point of origin. So, in the previous, in point light source only one point is there, here there is no point of origin. It is if the light sources are infinitely far away from the surface that it is illuminating. Sunlight is example of this one, that is distributed light source. Now, material. So, I have already told that there are two types of materials, opaque surface means non-transparent and transparent surfaces. When light is incident on opaque surface, part of it is reflected and some part is observed. Not all are reflected, some part is observed, some part is reflected. For example, when we see the red color in white light, all 7 spectrums are observed except the red one. Red is only reflected and we can see the object as a red color. Shiny material reflect more of the incident light. If it is a shiny material, it reflect more light, while dull surfaces absorb more light and reflect very less light. Transparent surfaces, for an transparent means these are for example bulb. For an illuminated transparent surface, some of the incident light will be reflected and some will be transmitted through the material. Now, diffusion reflection. So, there are two major materials are there, opaque material and transparent. Now, diffusion reflection. Rough or grainy surfaces scatter the reflected light. So, you can see here diffusion, rough surface, if it is there, it scattered the light in all the direction. This scattered light is called diffusion reflection if it is a rough or grainy surface. The surface appears equally bright from all viewing direction. In the case, the color of an object is the color of diffusion reflection of incident light. So here it is blue object is there, then it reflects the blue color only. If a blue object is viewed under a red color, it appears black since all the incident light is absorbed. Now specular reflection. Light sources created highlights, bright spots called specular reflection. If light sources create highlights and bright spots, so that is shown here in this diagram. One only point is highlighted, bright, it generates a bright spot, that is known as specular reflection. More pronounced are shiny surfaces. So in this example it is shown. So this is the only part which highlights or bright spot is there. So that appears normally with shiny surfaces or than the dull surfaces. On dull it is not possible. Next lecture, and this is about the light sources and basic definition of illumination and surface rendering model. Next lecture we will see the basic illumination model in detail.